as well. So once again, our rectangular coordinates is the xy. So it has its own, any point has its own x and y coordinates as such. So that point in red is in xy. So for example, in here, what quadrant is that? Giovanni, what quadrant is this xy at? Quadrant 2. Very good. Okay. Now, as you may notice on that xy, we can notice that it can be a part of a circle, right? With that radius, okay, and that angle, then that means that r theta is what we call the polar coordinates. Seeing it as what? As a part of a circle rotated theta degrees from the x-axis. Okay, now let's see. How does it look like? So in here are the following formulas. If the rectangular coordinate is xy, and you want to convert it into its polar coordinates to get the radius, you get what? The square root of the sum of the squares of the x and y coordinates. To get the reference angle of that polar coordinate, we need to get the what? The inverse tangent of that y over x absolute value. Again, as I put in here, it's just the reference angle. It depends on what quadrant it is to know what the actual angle is. Okay, so again in here, that will just be the reference angle. So it depends on the quadrant what you're gonna do to get that theta or angle. Okay, so let's figure out some cases in here and see how we can work on that one. Okay, let's read first in here number 8. Okay, let's read number 8 and see how we can work on that one. Okay, Brian, go ahead.
For the following exercises, convert the given polar coordinates to Cartesian coordinates. Remember to consider the quadrant at which a given point is located when determining 0 for the point.
Thank you. All right, so again, we got in here 6 negative pi over 4. So let's put it in here first. What's this? Number 8. All right, let's read our first step, Jenner, okay, on how to convert from polar to rectangular, okay? Thank you.
Make sure theta is in standard form.
Okay, so how do we make sure that your angle is in standard form? Again, when you say it's in standard form, that means it's what? Not coterminal, right? Means it should be positive less than 2 pi of radians, right? 2 pi radians. So with that being said, this is coterminal. So what do we do? Recall, guys. What do we do to make it positive less than 2 pi? You add 2 pi radians to that, right? So very good. So with that being said, since this is still coterminal, to make it standard, you add 2 pi to it, right? So again, the goal is to make it positive less than 2 pi. So that's going to be how much now? 6, what's that? Negative 1/4 plus 2 of a pi. Okay, so let's use our calculator for that. And again, in a calculator, you can just put in here the fraction coefficient, right? What's that? Negative 1/4 of a pi plus 2. Make it into a fraction. What did we get? 7/4 of a pi. Thank you. That is correct. So that is the standard form for such. This is now 7 pi over 4. Okay. After that, what do we do then? Right? Step number 2. Okay, we're gonna use the formula as follows. All right, okay, so let's read this one in here. Giovanni, go ahead. Yeah, step number 2.
Use formula x equals the absolute value of r cosine degree.
Theta,
Y-
right? Yeah, okay.
or radian. Y equals the absolute value of r sine and then radian again.
Thank you, right? So to get the x and y coordinates, we're gonna use the formula for such, right? So in here, the x in here will be as follows. Put in here, x is equal to what? 6. So absolute value of 6, cosine of 7 pi over 4. And y will now be what? Absolute value of 6, sine, what's this again? 7 pi over, no absolute value. Sine of 7 pi over 4. Okay, now let's see what those values are. Exact values, all right? So what are those exact values in there? So what is this? This is what? 6. And what is cosine? 7 pi over 4, guys. So you have to consider the quadrant as well, all right? So we're 7 pi over 4. What quadrant is that? 4, right? So if it's in quadrant 4, we are considering which one is positive and which one is negative between x and y. Quadrant 4.
Oh, positive x, negative 1.
Positive on the x, negative on the y, right? So with that being said, your x will be what? Positive 6, and this is what? What's cosine 7 pi over 4? That is what? Square root of 2 over 2. So please recall your what we call special angles as well in the unit circle for that, all right? So that's 6 times cosine 7 pi over 4 is square root of 2 over 2. And this one, what's this then? 6 times, and again, this is what? Sine of 7 pi over 4. What's that gonna be? Oops. Negative square root of 2 over 2. Okay, once again, in quadrant 4, x is positive, y is negative. Okay, and then after that, simplify them. What's gonna be the values for such? X will be what? What's 6 over 2? 3, right? So that's 3 square root of 2. And what's y? What's that? 6 divided by negative 2. Right? That will be what? Negative 3 square root of 2. Okay, so that will be it. And that will be our step number 3, right? Verify by graphing, okay? If that will be the case. So what is the point in here? Your point will now be the following. 3 square root of 2. And the other one is negative 3 square root of 2. Now let's verify. Is this xy same as that r theta? Let's consider that one and graph it in here. So here it is. Let's see how it looks like, okay? So here's what I'm going to do. I'm going to go here. I'm going to go to my polar coordinates. So that's my polar coordinates. Make sure it's in radians. Okay, again, make sure it's in radians. Put in the points in here. What are the points once again? We say what? 3 square root of 2. 3 square root of 2. Comma. The other one is what? Negative 3 square root of 2. Okay, so as we may notice in here, that is the point. Okay, that is the point. 3 square root of 2 and negative 3 square root of 2. Let me choose annotate this one. As you may notice in decimals, those are just approximated values. But again, typically in our homework, you need to get the exact values, right? Those square root of 3, square root of 2s, review those. please have your unit circle handouts with you. That will help you out, okay? So anyway, this will be what? 3 square root of 2, and this is your negative 3 square root of 2. Okay, right? Now, what is your polar coordinates? It says in here your r is equal to what? What's your r again? 6. So let's see, is that your r equal to 6? Let's check it out. If r equals 6, as you may notice, okay, that circle with radius 6 hits that point. Okay? Now, where is negative pi over 4? So here it is. Let me draw this one in here. If you notice from here, right, that is your 0 radians. And where's negative pi over 4? Since that's negative, that's what? Clockwise rotation, right? Pi over 4 units. As you may notice in here, okay, if you get that point over there, then this is how much? Negative pi over 4 radians. And that is your theta, right? So that is your what? This is your 6 as your radius, and negative pi over 4 as your theta in degrees, in radians. Got it, guys? Okay. Where is that 7 pi over 4, by the way? Again, the 7 pi over 4 is this one in here. Okay, that is your 7 pi over 4. As you may notice, the 7 pi over 4 angle and negative pi over 4 angle are what? Co-terminal angles, right? But once again, we use the 7 pi over 4 because that is our unit circle, or that's our standard form as well. Questions with what we did? Once again, we have verified that a circle with radius 6 and with angle negative pi over 4 will give us an x and y coordinate as follows. 3 square root of 2 and negative 3 square root of 2. And both are in quadrant 4. Questions? Now, let us consider now the what we call the reverse, right? What if we do the reverse for this, okay? Let's see some examples of the reverse for such and answer this one in here. Number 12. Let's read number 12 for such, okay? Here is number 12. Kate, can we read number 12, please? Can you see from there?
For the following exercises, convert the given Cartesian coordinates to polar coordinates with that. Remember to consider the quadrant in which the given point is located.
Thank you, right? So this one in here just tells us that your angle should be in what? Unit, degrees or radians? Radians, very good, right? Keyword, our key term is pi. If you see a pi, then we know that we are considering the radians value, okay? So radians value here. So let us consider number 12, right? So what's that? Negative 4, 6. And this now is the following, right? How to convert this time from, rectangular, right? In some cases, it's also called the Cartesian coordinate, okay, to polar. Step number 1. Miranda, can you see it from there? Step 1.
Get radius as r equals square root of x squared plus y squared.
Thank you, right? So whatever your x and y coordinates are, you square them, you add them. Basically, our Pythagorean theorem, okay? Or some distance formula as well, okay? So anyway, let's put it in here. What do we get as a value for such? What's our r? That'll be what? -4. Don't forget the parentheses, by the way. Squared plus 6 squared. Square root, by the way. Don't forget the square root. What do we get from here? Okay, so that's what? 16 and 36. Okay, so what's that? 16 plus 36. Calculator, guys. 16 plus 36. 52. Thank you. I would also put in here the following, right? In some cases, simplify radical if needed. Okay, so if it's needed, you have to simplify the radical, right? So in here, 52, is there like a perfect square factor inside 52? If that's the case, then you simplify it. Okay. Questions, guys? Is there something? I think it's divisible by 4, right? Because if it's divisible by 4, then at least it's, and 4 is a perfect square factor of, perfect square of 2, right? Let's see. 52 divided by 4. What's that? 13, right? So we can say that 52 can actually be written as, so what? 4 squared of 2 squared of 13, right? Thank you. That is correct in here. So 52, we can see that it has a perfect square factor, which is what? 2 squared, which is 4, right? Times 13. Okay. So with that being said, so if you can recall your simplifying factors or perfect square factors, you can bring this out and cancel that square, right? So that'll be what? 2 squared of 13. Again, if needed, simplify the radical, okay? Step number 2. So we got the radius, 2 squared of 13 as simplified form. Get theta, right? In this case, get theta reference angle first, right? Equal to what? Tangent inverse of the absolute value between y and x, right? So what's that gonna be? Again, take note, this is just the reference angle, okay? So what's your reference angle in here, guys? Tangent inverse of, what's your y? 6, all right? Over -4. Once again, absolute value, okay? Not considering their signs yet. Now, what's that gonna be in radians? Let's verify. What is that in radians, okay? So we can use our calculator for such as well for that, okay? So let's put it in here as such. Again, make sure it's in radians and put it in here as such, okay? Go to functions, go to tangent inverse, okay? Make sure it's absolute value, okay? Y is what again? 6 over -4. Again, do not forget it's absolute value, okay? Yeah. So as you may notice in here, it's not exact, so we can approximate that one to be, how much is that? 0.98, right? So we can, again, say in here that this is approximately 0.98 radians, okay? Once again, approximately 0.98 radians. And again, you can see on your questions how many decimal points it needs to be approximated to. Once again, this is just reference angle, which means it will bring us to step number 3, right? Okay? Yeah. Josh, let's read step number 3. Determine its quadrant and solve theta. Theta, thank you, right? So first, what quadrant is this? Negative, positive. X is negative, Y is positive. What quadrant are we looking for? Negative, positive. What quadrant is it, guys? 2. Very good, right? Quadrant 2. So if this is in quadrant 2, what formula do we use? So going back in here, your theta with respect to reference angle will give us quadrant 2. What does it say? Pi minus reference angle, alright? So with that being said, then since it is in quadrant 2, therefore our theta will be how much? Pi minus, what's that? 0.98, okay? 0.98 radians. So let's see how much will be our theta for such. And again, as you may notice in here, this will be what? Approximate value, okay? Once again, as you may notice in there, we are using approximate value simply because this is not a special angle. This is not pi over 3, not pi over 6, not pi over 4, okay? Let's put it in here. What's that gonna be once again? Pi minus, what's this? 0.98, okay? And we got how much? 2.16 radians, okay? So there we go. 2.16 radians for such. Approximately. Now, last step is the same as our last step for previously, right? So we say in here, verify by graphing. Okay, let's see. Let's verify it by graphing, right? So where is that? So since these are approximation, the verifying is by approximation as well. First of all, let's put in our point. What is our point? Negative 4, 6, right? So this is negative 4, 6. Here it is. See that one, guys? Okay, that's our negative 4, 6. That point. After that, we're going to put the r first. What's our r again? We said what? 2 square root of 13. So let's put it in here. 2 square root of 13. Get it? Okay. Verify. Did this radius hit the point? Yes, it did, right? So that's that confirms that sometimes it's called modulus as well, but in this case it's called the radius, right? It's 2 square root of 13, and yes, it hits that point, okay? And what's our theta again? So if you see this theta in here, you can put the theta to be what? From 0 to, what is our theta in there? It says what? 2.16, right? Let's put in here. If you click on that theta, you put in there from 0 to, what's that? 2 point, what's that?
16.
16. Did we put 16? Yeah, 16. So approximately 2.16. Get it? Okay, so as you may notice, if you put your r to be 2 square root of 13, and you put your theta to be what? From 0, what we call the initial leg or side, going to approximately 2.16. Once again, notice it's in radians, right? You see that one has what? A radius of 2 square root of 13 and an angle of 2.16. Okay, where is my pen once again? I lost it again, right? Okay, but anyway, my hand will be fine, right? So, okay, let's go ahead. So as you may notice in here, that that angle in here will be approximately how much theta? 2.16 radians. Okay, and again, this r in here is how much? 2 square root of 13 long, units long. Get it, guys? Okay, with what we did. Questions regarding that? Okay. Next time. Oh yeah, thank you, Robert.